Hello and welcome to this e-learning resource on probability, which is being produced as part of the Foundation Degree in Engineering. My name is Fergal Tuffy, and as I mentioned, the topic that we're covering today is probability. This comes within the Statistics and Probability heading, and at the end of this lesson, students will be able to calculate the probability that an event will occur. So what is probability is the first question. Probability is the likelihood that something will happen. And breaking that down even further, relative probability is how often an event happened over how often it was tried. So within this lesson, there are two options that we are going to consider. The first one is the add rule, and the second one is the or rule. So the add rule is if two events have to happen at the same time. So effectively two events have to occur, and in this case the probabilities are multiplied. For the or rule, however, we look at the case where if one event or the other event can happen, and in this case the probabilities are added. So refreshing this, for the add rule, if two events have to happen at the same time, so A and B have to happen at the same time, and if that's the case, the two probabilities are multiplied. And for the or rule, it's the case that either one or the other event can happen, and if this is the case, the probabilities are added. So as always, this is probably best explained through an example. Example 1. Two machines are in parallel in an engineering production line. These are machine A and machine B. So the probability of each failing at any given time is 0.4 for machine A and 0.6 for machine B. So within this example, we want you to find the probability that firstly, only one will work, and secondly, find the probability that both will work. So what do you think, and how do you think we will go about doing this? Here's the solution. There are two potential scenarios. So with only one working, there's the case that A is working and B is not working, and there's also the case that B is working and A is not working. So initially, for the first case that A is working and B is not working, the probability of that is 0.6 times 0.6, and when those probabilities are multiplied together, it gives the probability of A working and B not working of 0.36. Now, on the other hand, when we have the case that B is working and A is not working, the probability will be 0.4 times 0.4, which gives us an answer of 0.16. So therefore, the total probability that only one will work is adding the two probabilities that we just calculated together. So the total probability is 0.36 plus 0.16 is equal to 0.52. So the second part of the question is the probability that both will work, so both A and B are working. So to get this, the probability of this, we must multiply the probabilities together. So therefore we have 0.6 times 0.4 is equal to 0.24. So that gives us the probability that both will work. Now, moving on to example 2. A biased dice has the following probabilities. For position 1 on the dice, the probability is 0.1. For position 2 on the dice, the probability is 0.15. For position 3 on the dice, the probability is 0.1. The dice landing on position 4, the probability is 0.2. The probability of landing on the 5 on the dice is 0.2. The probability of landing on a 6 on the dice is 0.25. So, if the dice is thrown twice, calculate the probability that both dice are 6. Calculate the probability that both dice are 1. Calculate the probability that the first is odd and the second is even. And calculate the probability that the total score adds up to be 10. So pause the presentation and take a few minutes to have a go at example 2. So the solution. Firstly, it's the case that both of the dice land on a 6. So with the probability of position 6 being 0.25, the probability that both will be a 6, you multiply the two probabilities together. So the answer is 0.25 times 0.25 equals to 0.0625. Now for the second part, the case that both dice positions land at 1. So with position 1, the probability of it being 0.1, the probability therefore of both landing on position 1, you multiply 0.1 times 0.1 gives you the probability of 0.01. Now the third part, the probability that the first is odd and the second is even. So first of all, the chances of it landing on an odd number is, for position 1, the probability is 0.1. For position 3, the probability is 0.1. For position 5, the probability is 0.2. So adding these together gives us a probability of 0.4. Now the probability of it being an even, the second being an even, is, for position 2 the probability is 0.15, for position 4 the probability is 0.2, and for position 6 the probability is 0.25. So adding these together gives us a probability of 0.6. Now, part 4, the probability that the total score is equal to 10. So there are three possible options, three possible events that could occur that give us the total score is equal to 10. Firstly, there's the case that the dice are 6 and 4. Secondly, there's the case that the dice are 4 and 6. And lastly, there's the case that both dice land on a 5. So first of all, for the 6 and 4, the probability will be 0.25 for position 6 multiplied by 0.2 for position 4, and multiplying those together gives us a probability of 0.05. Now for position 4 and position 6, as above, the probability will be, for position 4 will be 0.2, the probability for position 6 will be 0.25, and multiplying those together will give us a probability of 0.05. So lastly, the probability of landing on position 5 of the dice is 0.2. So the probability of landing on the 5 and then the 5 again will be 0.2 multiplied by 0.2 is equal to 0.04. So there we have the probabilities of each one of the individual cases of those three. So therefore, to get the total probability that the score will be 10, what we do is we add these three possible events, these three possibilities together, which gives us a probability of 0.05 plus 0.05 plus 0.04, which gives us a total probability of 0.14. Now, a further example for you to have a go at for yourself. A box contains 100 copper plugs, 27 of which are oversize and 16 of which are undersize. So 27 are too big and 16 are too small. So if a plug is taken from the box, tested and replaced, and then the same is done for a second plug, determine the probability that, first of all, both plugs are acceptable. Determine the probability, secondly, that the first is oversize and the second is undersize. And the third part of the question is determine the probability that one is oversize and the other is undersize. Now I want you to have a go at this question yourselves, and after you have a go of it, email your answer to me at fergal.tuffy@swc.ac.uk before next Tuesday's class. So to finish, what is probability? So probability is likelihood that an event will happen. And within probability there are two rules that we have looked at. First of all, we have the add rule, and secondly, we have the or rule. So for the add rule, the two events happen at the same time, and in this case the probabilities are multiplied. For the or rule, it's a case that one event or the other event can happen, and to calculate this, the probabilities are added. So, well done on completing the e-lesson. Thanks very much for taking the time to go through it. I just want to point out that there are numerous resources available on the internet. For example, you can use Google or YouTube to search for numerous mathematics topics. So for this one, for example, if you type probability into YouTube, here is an example of a video that you might come across. Once again, thank you for taking the time to complete the C lesson, and any questions, please email me fergal.tuffy@swc.ac.uk. Thank you.